electromagnetic induction. Okay, so what is this? Whenever current carrying conductor is there, there is the magnetic field, right? This was told by whom? It was a law, we know, that Biot-Savart law. As per Biot-Savart law, whenever current is there, there is the magnetic field. So Faraday thought that if current is there, there is the magnetic field. Why the reverse can't happen? Means if there is the magnetic field, there be any current? So he has done some experiment. Okay, he has done experiment and he has proved that when B is there, there is I. When magnetic field is there, there is current. So for that he has done one experiment. Okay, so experiment is, this was the experiment. Okay, so this is your, here this loop is stationary, and the bar magnet he is bringing it inside and again taking it out, bringing it inside, taking it out. So when he brought this inside, he found there is a deflection in the meter. Okay, in the meter. So this deflection shows that there is the current. So this magnet inside, if the deflection is the left hand side, and when taking it out, withdrawing it, the deflection is right hand side. Okay, so that means it is alternating. It is flowing, sometimes the current is flowing clockwise, sometimes the current is flowing anti-clockwise, right? So due to this movement, to and from motion. Okay, why is it happening? So he has told that the number of field lines, here, this field lines joining this loop, means connecting with this loop, is changing. When you are here, you see there are 1, 2, 3, 4 lines, isn't it? When I take it outside, it may be 3 lines or 2 lines, or when I bring it closer, all this 1, 2, 3, 4, 5, 6 lines will be linking with this, isn't it? So this linkage, change in the linkage produces the current in it. Okay, and here this is the dynamic way he has proved. Okay, so this magnet is dynamic, isn't it? Now here you see both are stationary. What he did, when he switched on the current, so current is there, means B will be there, this B will connect with it, so deflection will be there, isn't it? So this deflection, let it be in the left hand side. Now when he switch off the connection, this switch connection, there is no current in this, then what will happen? The B will be collapsed. So collapsing means here also number of line linkage is changing, isn't it? Before it was 10, now 8, 9, 8, 7, 6, 5, 4, 3, 2, 1, isn't it? Like that is becoming 0. So then also there will be a deflection, but this deflection will be in the right hand side. Before it was in the left hand side, now it is right hand side. Okay, so while building up, suppose the deflection is left hand side, while collapsing the deflection will be right hand side. Here no motion is there, right? Here there is no mechanical motion. So this is the static way of generating it. So this is the two ways he has done the experiment, and he found that whenever there is the B, there is the current in it, because deflection is there, means current in it, isn't it? So this phenomena is known as electromagnetic induction, Faraday's electromagnetic induction, because he only discovered it. So this is called Faraday's electromagnetic induction. Faraday's electromagnetic induction, okay. So Faraday's electromagnetic induction says that whenever there is change in linkage, and one more thing you should remember, that it is a loop, it should be a closed path, then only the current will flow, right? Current cannot flow in a open path. Whenever there is change in linkage, magnetic flux linkage, better, magnetic flux, or magnetic flux means phi B. Okay, magnetic flux linkage within a coil, within a closed loop, and EMF is induced, and EMF, that is E, is induced in the loop. Okay, this is what the electromagnetic induction is induced in the loop. Correct? That whenever there is the B, there is I. Whenever there is the magnetic field, there is the, so when you're switching on, I is there means B will be there, isn't it? Current will flow, so due to that B will be there, that B will link with this loop, and it should be very close, okay, magnetically coupled, okay. So then only this phenomena will occur, right. We will find out what is the amount of that magnetic field, what is the amount of that magnetic field it can generate, okay. That is using Faraday's law of electromagnetic induction, okay, electromagnetic induction. Faraday has given the law. He told that the induced EMF will be equal to minus of minus, okay, this minus, why it is coming, I will let you know. So I minus of d phi b by dt means rate of change in flux linkage. So minus of d phi b by dt, this is what, this is for one loop, this is for one loop, okay. And if it is n number of loops, then it will be minus of n d phi b by dt, okay. So this is what the Faraday's law of electromagnetic induction. Now let us discuss about phi b. What is this phi b? What is this phi b? So suppose this is a surface, this is a surface, okay, and from here electric field lines is coming out of this surface, okay. So like this electric field lines are coming out. So how many number of electric field lines are coming out from the surface? This surface area is A, okay. So that will be nothing but phi is equal to, let me write it here, phi b is equal to integral of b dot dA, okay. dA is nothing but surface area, that is a vector surface area, okay. So suppose this is the surface, then this is dA, this area is dA, then perpendicular to this is called the vector dA, okay. Perpendicular to this is called the, this is the surface area, perpendicular is the dA. Now if dA and B, this is your B, this is your dA, dA and B makes theta angle, then what will be the dot product? Dot product will be B dA cos theta or not? B dA cos theta. So this will be, B is constant because B will be the source, isn't it, that bar magnet or something will be there. So B I can take it out, isn't it, and cos theta dA, right. So phi b will be how much? Phi b will be B A cos theta, right. This is the phi b. If B is parallel to A, in that case what will happen? Theta will become 0 degree. So phi b will be BA, right. If B is parallel to A, then phi b will be BA. So this is the way we can find out or calculate the E value, right. So this is the magnitude of E, how to find out, okay.